Welcome to this career guidance program brought to you by the Uganda Institution of Professional Engineers. At the institution, as a way of giving back to community, we carry out career guidance to career path to youngsters, to students at higher level, parents, teachers, and to everybody else so that they know how to choose careers. The Uganda Institution of Professional Engineers has assigned me, Engineer Hans J.W.B. Mwesigwa, a past president, with the assignment of looking around for its members and interviewing them. And these are members in engineering-related schools, industries, so they can show us what it is to become an engineer. Right before me is a student, or rather a former student, because he's just waiting to graduate, who has studied and finished chemical engineering and was a member of this Kyambogo Association of Engineering Students. And that association, its members belong to the Uganda Institution of Professional Engineers. Timothy Obbo.
Yes.
You are welcome, Timothy.
Thank you very much.
And kindly tell us background about yourself.
Well, my name is Obbo Timothy, and my education background stems from St. Mary's Boarding Secondary School, Chitende, where I did my O-level, then further proceeded to A-level. I did physics, chemistry, and math before moving on to Kyambogo University to pursue a bachelor's in chemical and process engineering that I have recently completed. While there, I was a member of the Association of Chemical Engineering Students, as well as a student member of the Uganda Institution of Professional Engineers. And currently, I'm actively seeking for trainings and employment within my related field of study.
Okay. And now we come to this complicated maze of things, pieces that I don't know whether it's a computer or that. What is that?
Well, from a distance, this seems complex, but for starters, it is an automated liquefied petroleum gas fire suppression system. So it is a system that is designed to automatically detect and suppress fires that are resulting from the gas that we use in the cylinders for cooking. So in simple terms, it is an automatic fire extinguisher, but particularly for the gas that we use for cooking at home.
Okay. Is that for only cooking at home, or can it even be used at a petrol station or anywhere else?
Well, while developing the system,
yes,
it was initially centered for residential settings. But having developed it, it gained more applications in industrial settings like the petrol stations, like LPG storage facilities, and transportation, like in the trucks that are carrying these gas cylinders from one place to another location.
Fine. Before we delve into the chemistry part of it,
yes,
tell us, lead us through, how does it work? You've told us that in simple terms, it is a fire extinguisher of sorts.
Yes.
Extinguishing fire from gases.
Yes.
How does it work?
Well, this system is made up of major components, 3 major components. First is the sensors. It has sensors that are detecting the gas leaks.
Am I seeing them here?
Yes. This right here is a sensor.
Okay.
It's a gas sensor. I have a flame sensor, and I also have a temperature and humidity sensor. So these sensors basically are for detecting the leakages that we have with the gas, and then also having detected those leakages, it has actuators.
What's that?
Actuators are components that intrigue a mechanism in case they detect something.
Yeah.
So in case a gas leakage is detected, in case a fire is detected, it is the actuator that tells the components that now turn on the extinguishing system. Those are the actuators. Then
What is the actuator here?
the actuators are these.
Okay.
These.
So small. Fine, but that's
Very small.
modernity.
Yes.
Yeah.
Then lastly, it has microcontrollers. These that you see here are microcontrollers. What microcontrollers basically do is to process the data from the sensors, because the sensors are going to interact with the environment around them and they'll send information. But this information must be interpreted for the system to make a decision. So the microcontroller processes and interprets this information from the sensors for the system to work. Yes, so basically those are the major components of the system. In addition, it has a few components like the alarm system and the blower system. The blower
Alarm is
system,
clear. It will make alarm. Everybody
yes,
knows
the alarm is
fire.
basically to alert.
And the blower, this is
and
the
then
blower.
the blower
Yes.
is the one that extinguishes the fire. Remember, it is a fire suppression system.
Okay.
So this blower is the one that extinguishes the fire. So basically that is what the whole
It
system is
extinguishes
composed of.
with what? Carbon dioxide? What does it bring on?
Yes, it extinguishes using a powder.
Yes.
This is sodium bicarbonate.
Okay.
What people know as baking soda.
Baking soda.
Yes, you
So
can-
these are times you are not going to bake, but you are going to
Yes.
take, to stop the fire.
Yes. So baking soda is used because it has very good practical application in suppressing gas fires, particularly LPG. Yes. So the baking soda is the one that is applied in the blower system. So in the case that the system has detected a fire, the blower puts out the baking soda that reacts with the fire and produces carbon dioxide, which is a bad conductor of fires.
Of fire.
Yes, it suppresses off the fires.
Yeah.
So that carbon dioxide is the one that extinguishes the fire. The
So
carbon
that's the
dioxide-
bit of chemistry that viewers need to remember about
Exactly.
carbon dioxide and the way it extinguishes.
Yes.
Continue.
Yes, so when the baking soda is given off, it is heated up by the fire, it gives off the carbon dioxide, and this carbon dioxide extinguishes the flame. So that is what the system does when extinguishing the fires.
Okay. So once again, here we are, you are telling us that from the study of chemistry and from the study of chemical engineering at the university, you've come up with an application that can help our homesteads to put off fire.
Yes.
Are you saying these gases that many people buy, and there are children in where the parents go to work and they leave behind a maid, are you saying that the system will switch itself on? Supposing there is fire like this,
Yes, yes.
within 3 hours,
No.
within,
Actually, for the tests that have been carried out with this system, it takes averagely 3 seconds. 1 to 3 seconds
chaka, chaka, chak.
for it to put out a mechanism of suppression.
Can you do this for our households?
Yes, I can do this for the households.
Are you starting, when are you starting the prototype? What do you need? Money, what? Because many people say, first and foremost is money.
Yes, well, since I've recently concluded the development of the prototype and what you can see here,
Yes.
I have to carry out field tests. These field tests will entail placing the different prototypes in different areas for people to try them out. So when they try them out, I expect to obtain feedback from
Yes,
them
yes.
and the data basing on the performance of the system. So I'll have to look at the feedback of the final client. How is the system working? What do you need us to improve?
So, Obbo, what you are telling
I
us is
refine
that
that.
you need to work out a prototype, and,
Yes.
and with the viewers, we are going to give the man's names, Obbo, Timothy, and his telephone number, that he is able to use engineering to solve our domestic problems. Yeah?
Yes, very much.
And here, if you had it, you can vow that you can make us a prototype and use your engineering, particularly chemistry, particularly your membership at the Uganda Institution of Professional Engineers and the association here, and your good results to make something useful for our communities,
Yes, and not just useful,
Yep.
but effective.
but effective.
Yes.
let's touch about Uganda Institution of Professional Engineers. So, what relevance do you feel that it has helped you being a member? How does it help you to advance?
Firstly, with the professional mentorship, we usually have webinars, we usually have conferences with some of the members who are professionals in the engineering-related fields, and these people give us a lot of professional mentorship on how to carry on with the journey of engineering, how to carry on with the different projects, how to navigate the working sector, how to navigate your knowledge of engineering and use it for practical applications, how to be a practical engineer with not just the class knowledge, but with the knowledge that you can put out to solve a society problem. In addition to that, the Uganda Institution of Professional Engineers has also provided us with support and resources. They give us different articles to read on. They provide us with a lot of insights concerning the engineering field that you can read and use to advance your career in engineering. And that has been very helpful to us as student members who are just learning and want to develop careers in the field of engineering. So it has been very professional.
Wonderful, wonderful. Timo, you might even add that they have sent me
yes.
to bring you out and put you on the arena.
Yes,
yeah.
And also in addition,
yes,
the institution has given us opportunities for networking. We have happened to network with a lot of people in the field that are relating to what we are studying right
wonderful.
now.
Yes.
And that has given us a lot of go-aheads in the field.
Now, Timo, let me take you back to the long ago days when the chemistry in the senior 1,
yes,
chemistry in the senior 3 seems to be a complication of mazes of things like that, you know?
Yes.
I also appreciated it only when I was at the university,
yes,
that chemistry was useful. But take me back, how did you discover this chemistry to be your friend, to move with it?
Yes, yes.
And I want to take you as far back as senior 1.
Yes.
And relate to me how eventually chemistry became that main subject that took you for chemical engineering.
Well, surprisingly, I started with very high failure rates of chemistry. Yes, but then when these failure rates were so high, I kept on wondering, why do I keep on failing chemistry? What is the problem? Why are these things so complex? Because I was from a primary setting, I'm used to doing simple things, and here I have to navigate inorganic chemistry, navigate organic chemistry, physical chemistry. So it was quite challenging for me, and this triggered a mindset of being inquisitive.
Yeah.
Why are we studying complex things? Where are these things taking us?
You are telling us the organic chemistry seemed complex.
Very complex.
Remind us again, what is the organic chemistry about?
Organic chemistry is where you study about basically the knowledge of different hydrocarbons, the different mechanisms of how these components are relating to each other to come up with different, I would call it combinations, yes, of the different hydrocarbons, the compositions, what are the classes.
Yeah.
So it was very diverse, as I can mention.
Yes.
And it was quite challenging.
And so here you are being challenged.
Yes.
It is chemistry. Normally one would have expected you run away.
Exactly.
Go to science, rather history, go to geography, go to whatever. But here you are, you stayed.
Yes.
Give me that nitty-gritty. Why did you stay?
Yes, exactly. Why I stayed was because I wanted to know where exactly are we applying the knowledge of these complex things that we are studying in class. Will we stand out one day in the world and solve a problem using this knowledge or not? Are we just going to study and leave it here in class? So that kept me wondering, should I really pursue chemistry?
Can you tell me maybe in your brain or remembrance, was that in senior 2, term 1? Could it be senior 3? Could it be senior 5? About when do you think you started realizing the need to understand what this bloody chemistry is all about?
Well, that was about the beginning of my senior 3. Yes, because senior 1, senior 2, I was finding things challenging and, but I would see people in the higher levels, like A level, taking on chemistry. So I would ask myself, why are these people taking on the subjects that I'm finding challenging?
Okay.
Yes?
Okay.
So around senior 3 is when I realized that, okay, people are taking this on. Why are they doing this? Where is it going to be applied?
Okay. Now, let me bring you back to the career guidance. We note that if a student has the ability and the capability, the head is able to understand what is being taught. Next, he needs to have the interest or the passion. Now, in your case, did you at once know that you were capable of doing this chemistry, or were you busy failing and you didn't even know whether you had the ability? Before I come to the interest and passion that you eventually grew.
Wow. So I didn't have the thought of I'm able to do this, not until I reached my senior 3, when I kept on wondering why people are taking this on. So I told myself, let me give this time. Let me concentrate on the chemistry. Let me try to navigate and see what is being difficult.
What were your results like? Were you busy getting F9 or
no.
what results were you getting around that senior 2, senior 3?
I was
D2?
getting about C4,
C4.
C5, 60s, 50s.
Yeah.
Yes. So I was like, what can make me get the 90s? Yes. So I gave the subject time. In giving the subject time, I realized the beauty of chemistry.
Yeah.
I started understanding the mechanisms.
Fine, now I get you. So when do you start getting a passion for chemistry? At S5 or S6 or what?
No, I started getting the passion in senior 3.
In senior 3?
Yes, having given the subject time, I'm now understanding the things.
Yeah.
I would go to the lab and what I studied in class is being applied.
Wonderful. Let's get now to the university. You come to Kyambogo University. Well, I want to ask you, what is it that you eventually did not like, which could have made you go back if you had time to change from this bloody chemistry?
What could have made me change? Wow, when I came to Kyambogo, having pursued chemistry at A level and passing it highly, I thought I'm good to go. Chemical engineering is a walkover. When I reached here, amalgamating the knowledge of chemistry and physics to come up with the engineering concept was quite challenging for me. I started facing difficulties with certain course units that were complex. I would keep on asking, did I really make the right choice to do this course? Because certain course units seemed challenging, and here I am already pursuing the career. Yes, so I felt like I should have changed that, but...
And how did you overcome that?
How I overcame that was with continuous learning. Yes, I came to realize that if you give time to a challenging concept, you can actually overcome it. Research more, obtain more knowledge.
Timo, I like that. Together. I like that. Let me take you further to, I asked you the ugly part.
Yes.
But as you at the university, what are the beauties that you were enjoying out of taking chemistry? In this case, chemical engineering.
Out of taking chemistry?
Yes.
Wow. I've benefited a lot out of taking chemistry. Firstly, I've developed such projects. And these projects are solving problems for the society.
Okay.
Yes. But all this I've developed with the knowledge that I've obtained from the university. Yes. Also, I've happened to be a member of the Uganda Institution of Professional Engineers.
Yes.
Yes, just because of taking on the engineering course with the knowledge of chemistry, I've been able to network with several professionals in the field. This has given me a go-ahead in my career development. This is a very big benefit to me because when we are here, we don't know which career paths to take, but that has helped me network, and I've ended up benefiting a lot with my career development. I've grown and I know what I want to do in the future.
Wonderful. Now, it's unfortunate that we don't have a lot of time, but it's been wonderful meeting you. Timothy Obbo, a man who has studied chemical engineering, and you're about to graduate,
Yes.
and you are out looking for a job,
Yes.
but you have shown us that you have used the chemical engineering or chemistry to make a product.
Yes.
So I want to give you a chance to
Yes.
tell the world out there,
Yes. Yes.
to tell your youngsters,
Yes.
what would be your message to them?
To the youngsters and the youth out there who are thinking on pursuing engineering careers, I would urge you all to take them on so that you can use this knowledge of science to come up with solutions, engineering solutions in particular, that are helping in solving society problems and challenges. And to the world, I would urge you all to adapt to the automated LPG fire suppression system to enhance your safety in your residential settings, industrial settings, and all other places where you're using this gas, because it is a very flammable gas and it costs both our life and damage to the property that we are using. So this is a call to adapt to an automated system that is proactive at detecting and suppressing fires that are erupting from LPG gas. Thank you.
Wow. In other words, ladies and gentlemen out there, we are seeing chemistry at work through a young man called Timothy Obbo, who has finished chemical engineering at the University of Kyambogo and has shown us impeccably this small gadget here. It can detect
And suppress
or stop the fire.
from the gas.
And wherever you are, it will let you know that the maid has done the impossible or whatever.
Yes.
And it will go on and suppress and kick out the fire.
Exactly.
And I think what he's saying, all he needs is money or facilitation
Yes.
to complete a prototype
Yes.
so that we can make it an industrial enterprise.
Yes.
And on this note, I would like to come to the end of this interview to remind that this is the Uganda Institution of Professional Engineers at work, doing career guidance, showcasing it with its members. And here we talked about the use of chemistry through chemical engineering in suppressing fire in this case, but in doing so many other things. My name is Mwesigwa, Engineer Hans Mwesigwa. I'm the consultant and enabler at the Uganda Institution of Professional Engineers to carry out career guidance. Ladies and gentlemen, I thank you.